Hello students, we are going to study quantum theory and photoelectric effect in this class. Okay, we were studying in the last class what the particle nature of the electromagnetic radiation. Okay, in that we have covered the topic black body radiation. Okay, next was photoelectric effect, isn't it? So this photoelectric effect could not be understood by what the classical electromagnetic theory of radiation. Okay, this classical electromagnetic theory of radiation failed to explain what the photoelectric effect. So Max Planck in 1901 gave his theory, quantum theory of radiation, and this could explain what the photoelectric effect. So let us understand the main points of quantum theory. Okay, so first is the radiant energy is emitted or absorbed discontinuously in small pockets of energy called quanta. So here we are seeing what this energy is emitted or absorbed, okay, in a discontinuous manner. How we will understand that? Suppose if you are eating your food, okay, you eat your food one by one, bit by bit, isn't it? It is not that you are opening your mouth and the food is just entering your mouth, isn't it? So you are eating your food in what? In a discontinuous manner. Likewise, this energy is emitted or absorbed in a discontinuous manner in small pockets of energy known as quanta. Okay, this each wave pocket or quantum is associated with definite amount of energy. So if it is absorbing or emitting, okay, so this quanta, this small discontinuous form in a discontinuous form in pockets, we are saying, okay, in quantum it has a definite amount of energy. Okay, and if we are talking this energy about light, it is known as photon. Okay, now in the previous class, black body radiation, we have studied in that class, okay, that energy is directly proportional to frequency. Okay, so here in order to remove the proportionality sign, okay, we have used a constant, and that is the Planck's constant, whose value is how much? 6.625 into 10 to the power minus 34 joule second. Okay, so here we are talking about what the energy of a photon of light in terms of what? Wavelength and velocity c. Why we are writing here velocity c? Because this is compared with, or this is of what? The speed of light. And here, so we are taking the energy of photon, so here it is represented as what? C. Okay, and now here E is equal to what? H nu, isn't it? Or E is equal to h c upon lambda. From where this c upon lambda came? Because nu is equal to c upon lambda. Okay, now the next point, the body can emit or absorb energy only in the terms of integral multiples of quantum, and energy is quantized. This is what? E is equal to n h nu, where n is the integers like 0, 1, 2, 3, 4. How we will understand this? Suppose if you are stepping down a ladder, okay, suppose you are standing here, okay, you are stepping down the ladder, okay, you will come over here, okay, you can't go over here or here or here. Likewise, we can write what? 2h nu or 3h nu, but you can't write 1.5h nu. Okay, getting? And so we are saying that energy is quantized. Now we are going to study photoelectric effect, which was explained by whom? Einstein. Okay, so here you can see the whole setup of the photoelectric effect. You can see a battery, emitter, vacuum chamber, electrons, metal surface, detector. Okay, and you can see over here we are providing light to it. Okay, so here if there is any metal, okay, suppose first if there is any metal, their electrons are held together with the electrostatic forces, isn't it? The electrons can't move out of its own, isn't it? So there must be certain amount of energy in order to remove the electrons, okay, and for that this electrostatic forces bonding must be broken, isn't it? So there must be some minimum amount of energy which can provide or which can remove this electrons, and that is known as what? Work function. Okay, and when it is done with the help of light, it is known as what? Photoelectric work function, and it is denoted by W naught. Okay, now we have studied about the energy, the minimum energy required to remove the electrons, isn't it, from its outermost orbit. Okay, so now you know that what energy is directly proportional to frequency. So the incident photon should have certain minimum amount of energy, isn't it, in a minimum amount of frequency. Okay, it should have, as E is directly proportional to mu. Okay, what happens? This incident photon should have certain minimum amount of frequency in order to remove or eject out the electrons from the outermost surface of that metal. Okay, so here that is frequency is known as threshold frequency, or it is known as critical frequency. Okay, so here what critical frequency or threshold frequency is denoted by what? Mu naught. Okay, so here we can say both are doing what? They are the minimum amount in order to eject out the electrons, okay, from its outermost orbit. So H mu naught is equal to W naught. Okay, so here what is H? H is Planck's constant. Now let us understand the photoelectric effect now. Okay, so here there is a metal surface, okay, connected to a battery. Okay, so here what will happen? We will be seeing what? Here there will be surplus of what? Electrons. Okay, now we are providing what? Light to this metal surface. This light can be of any color. Let us take the color red. Okay, this red color, if we are going on increasing its intensity, or you can say it increasing its brightness, okay, what we will see over here? Nothing is happening. Okay, whatever intensity we are increasing, brightness we are increasing, going on increasing it, but nothing will be happening. This circuit will not be completed. It can be shown by the emitter. Okay, so now here what works? Here frequency works. The threshold of frequency should be overcome. Okay, so we have to provide with certain frequency of a light over here so that it can eject out the electrons. Okay, if we are providing the frequency that is only the threshold frequency, it means the minimum amount of this frequency to eject out the electrons, what will happen? The electrons will be ejected out, okay, but it will not move. Okay, for that we have to provide certain more energy, okay, and that is what in the form of kinetic energy. Okay, so here what happens in this? How can we denote it? H mu is equal to H mu naught plus half MeV square. Me stands for mass of the electron. Okay, this is the extra energy which we are providing in order to the movement of electrons, because when we are providing this threshold frequency, yes, the electrons will be ejected out, but it will not move faster. The more the energy, the more faster it will move. Okay, so here what happens? If we are saying this frequency is equal to what? This is the threshold frequency plus the kinetic energy. This can be written as kinetic energy. This half MeV square can be written as kinetic energy. Okay, it depends how much we are providing the kinetic energy. Suppose if the frequency of light which we have taken is 3, so what happens? And it is required only 1. Okay, so if this becomes how much? 2. So if this more 2 which is present over there, it responds to the what? The faster it will move, accordingly the more the kinetic energy we have provided. Okay, so now this is only here. What is this kinetic energy? This is being related only over here. Okay, frequency is equal to threshold frequency plus kinetic energy, and when we want to take out the kinetic energy, okay, so what happens? The frequency minus the threshold frequency. So what is the role of intensity over here? The role of intensity is only just what? That the number of electrons will be ejected out more if the intensity is more. Okay, but the main factor which rules or governs the photoelectric effect is the frequency. It is related to frequency only. This photoelectric effect is understood in terms of frequency. Okay, the more the frequency, the more the faster the electrons will be ejected and moving towards the detector, and the circuit will be completed. Okay, so now here we have studied about photoelectric effect, black body radiation. Okay, wave theory also we have studied. Okay, so these all explains that yes, it is having wave theory also and particle nature also. So this explains about the dual nature of the electromagnetic radiation. Okay, so this is all for today. Take care. Have a good day.